Air Conditioning Service Calls, Part 2.
Hi, I'm Alan Pratt. Sealed system problems are a common source of trouble in refrigeration and air conditioning equipment. In this program, you'll see 2 service calls dealing with equipment that has this type of problem. But let's start by taking a look at a common sealed system problem, refrigerant leaks.
When refrigerant leaks, air conditioning and refrigeration equipment loses its cooling capabilities. Air and moisture are allowed to enter and contaminate the system. In addition, leaking refrigerant reportedly harms the ozone layer of the Earth's atmosphere. A sealed system leak can sometimes be detected by sight and sound. Look for traces of oil around tubing, fittings, and coil surfaces. If the leak cannot be located by sight and sound, special leak detection equipment and solutions can be used, such as bubble solutions, electronic leak detectors, ultraviolet light, and pressurizing systems.
Now let's take a look at a typical service call where you'll need to pressure test a system in order to find the refrigerant leak.
Hello, I'm Natalie from Protek. I heard you having problems with your air conditioner.
Yes, it was fine until this morning, and all of a sudden there was no cool air.
What's the setting that you keep on the thermostat?
Oh, I always keep it at 75.
Can you show me to take a look at it?
Hey, it's hot in there. You're welcome to go on in. I'm going to stay out here.
All right, try myself.
Start by verifying the problem. The thermostat is set to 75 degrees, but the room temperature is 80 degrees. The air velocity feels adequate, though it is clearly not cool. Outside, you see that the condenser fan and compressor are not operating, even though the unit disconnect is turned on.
The compressor failure could be due to an electrical or sealed system problem, so you'll need to check both areas to determine the cause of the problem.
A voltage check at the contactor shows that the correct supply voltage is present. However, a low voltage check at the contactor terminals shows 0 voltage. This explains at least one reason why the compressor and condenser fan are not running. To find out why, you'll need to check the electrical schematic. The schematic shows a low-pressure safety switch. This could be the problem. A voltage check across the low-pressure switch leads indicates 24 volts. This tells us that the low-pressure switch is open, preventing a completed 24-volt circuit to the compressor contactor.
So, the low-pressure switch is open. Why? Well, either the switch is defective or the switch is good, but pressure in the sealed system is low.
Check the pressure first by attaching manifold gauges to the sealed system. Both the high side and low side gauges show 0 psig. This shows that the low pressure switch is probably okay, and the problem is that the system has lost its charge.
A 0 psig reading on a sealed system is major enough that you can usually see the leak, and sometimes even hear it. But in this case, there's no obvious leak. So you need to pressure test the sealed system using specific steps required by EPA. Let's take a look at them.
To begin, turn off the unit. Then pressurize the system with a trace amount of R22 refrigerant. Next, use a cylinder of nitrogen equipped with a pressure regulator and a pressure relief valve to increase the pressure of the system to about 125 psig. This should be enough pressure to force the refrigerant leak. Then use an electronic leak detector to check the system. Once you've found the leak, you can vent the mixture of R22 and nitrogen to the air following EPA regulations. This method of leak detection is also recommended on systems which use other refrigerants, such as CFC-12, CFC-500, and CFC-502.
Compressed gases can be dangerous if you don't handle them with respect. So here are two rules that you should burn into your memory. First, when you're pressurizing a system, never use oxygen, compressed air, or compressed or flammable gases like acetylene or propane. And second, only nitrogen should be used to pressurize HFC refrigerant systems. Okay, now back to that service call.
Once you've found the leak, explain the problem, give an estimate of what it will cost to correct it, and get permission from the customer to perform the
Well,
repairs.
do what you have to.
Then repair the area where the leak occurred. You should also install a liquid line filter dryer to remove moisture or contaminants that may have entered the system. Next, flush the system with nitrogen to dry it out and remove any contaminants caused by the soldering. Then, use a vacuum pump to evacuate the system to 500 microns. Finally, turn the pump off and let the system sit idle for 5 minutes to assure that it's tight and all the contaminants have been removed. Observe the compound gauge and micron gauge. They should show no rise in pressure.
After the system has been repaired and cleared of contaminants, it will need to be charged with new refrigerant. In this service call, the unit will be charged by the superheat method. Here's how it works.
Begin by placing an insulated temperature probe on the system's suction line. Then determine the wet bulb and dry bulb temperatures of the indoor air and record them on the service invoice. Next, measure the outdoor dry bulb temperature and record it on the service invoice too. Plug the conditions of the indoor and outdoor air into the charging calculator to determine the required superheat for the system under the current operating conditions. Next, open the refrigerant cylinder valve and bleed the air from the center line of the manifold gauge. Then open both the high side and low side valves, allowing refrigerant vapor to enter the system and equalize its pressures. This will prevent the system from operating without refrigerant vapor cooling the compressor. Next, close the high side valve and turn on the unit disconnect. Continue to add refrigerant vapor to the low side of the system until the correct superheat and suction line temperature are reached according to the charging calculator. Once the correct superheat is reached, operate the system for about 15 minutes. Next, determine the wet bulb and dry bulb readings of the indoor air. Record them on the service invoice. Next, measure the actual supply air temperature. It falls in line with the calculator's requirements for the load conditions the system is dealing with. Complete the service call by explaining the charges on the invoice, making sure the paperwork is complete, and answering any questions.
Now let's take a look at another typical service call. In this instance, the technician has received a call from a residential customer whose air conditioning unit is not running.
As always, talk with the customer as soon as you arrive to gather information about the system and the problem.
Actually, it just started this morning. I noticed it wasn't working, and when I went downstairs, I noticed that the circuit breaker had tripped. So I reset it, but it just kept tripping. And after I reset it a couple times, I figured I'd better call.
Okay, well, for future reference, you really want to be sure not to reset a breaker more than one time once it's tripped. And that's more for safety reasons than anything else.
Oh, okay. Well, you know, I didn't know that, so I'm glad you told me.
Okay, fine. Would you show me where the panel's at, please?
Sure.
Because the circuit breaker tripped immediately after being reset, it's logical to suspect that there is a short somewhere in the unit.
Next, look for obvious signs that could create a direct short, such as loose, burnt, or broken wires that could be touching the case of the unit, or burnt controls which could have shorted. In this case, everything looks okay. Next, check the voltage across the line supplying power to the condensing unit. In this case, there is no voltage present, confirming the fact that the breaker is off. Then isolate the condenser fan motor leads from the contactor and check the resistance of the condenser fan motor windings. The motor windings are okay, and there is no indication that the windings are shorted to the motor case. Finally, remove the compressor leads from the contactor and capacitor, and use the ohm meter to check the compressor motor windings to ground. The resistance check to ground reveals that the compressor motor windings are shorted. This means the compressor must be replaced.
Okay, you've now found the root cause of the problem, but there could be another problem. Shorted motor windings produce heat, and if there's enough heat, it could burn the refrigerant, and that can form hydrochloric and hydrofluoric acids. So when you find that a compressor has a shorted or open winding, always use an acid test.
In this case, the acid test confirms that the system is not contaminated with acid, so you can go ahead with replacing the compressor. But first, explain the problem, estimate what a new compressor installation will cost, and get the customer's approval. Start by turning off the electrical disconnect and lock out and tag the system. Then recover the refrigerant from the system. Once all the prep work is completed, remove the old compressor from the system and install a new one. You should also install a liquid line filter dryer and suction line filter dryer. Once the components are in place, flush the system with nitrogen to remove contaminants. And test the system to make sure there are no leaks. Next, evacuate the system and check to see that the proper vacuum level holds for a minimum of 5 minutes. Find the total charge required for the system in the manufacturer's charging instructions, and then charge the system. Now you're ready to test the system. Reset the breaker, remove the lockout and tag, reinstall the disconnect switch, and turn the unit back on. After about 15 minutes, check the wet bulb and dry bulb reading of the return air. Record this information on the service invoice. Then use a charging and airflow calculator to determine what the supply air temperature should be under the recorded conditions. In this case, the temperature of the supply air falls in line with the calculator's requirements for the load conditions the system is operating under. Finally, use a manifold gauge to check the low side and high side pressures of the system and record them on the service invoice. To complete the service call, explain the charges on the invoice, make sure all paperwork is complete, and answer any customer questions.
Well, that's it for this program. I hope you've gotten some ideas about how you can sharpen your troubleshooting and customer service skills when you're dealing with sealed system AC problems. So long.